Good morning, students. It's good to be with you this very blessed Saturday morning. My name is Edu Triumph, the contact tutor for computer studies. Today, we are going to look at 2018 assignment. 2018 assignment. The purpose of today's class is to guide you on how to have your 2018 assignment done. So I'm going to take you through how to approach the assignment and how to have it done. Computer studies. Now, by now, I assume that you have seen your assignment, you have gone through it, and perhaps you have started even doing the assignment or started reading for the assignment. You must have gone through it. The assignment with you consists of 11 questions. You must answer all the questions in the assignment. I want to beg of you here, my beloved student, that you should please be involved in the doing of your assignment, because the assignment prepares you for the 2018 examination. What it means is that if you are not involved in the assignment, comes 2018 examination, you are going to face problems. So don't give your assignment as a tender to people to help you. Now the assignment, as I said, has 11 questions. So I'm not here to give you answers. Edo is not here to give you answers. What Edo here is to guide you on how to approach the assignment. Number one, the assignment should be typed. I want it typed so that it can easily be read. Now, if you look at the assignment for computer studies, it has a lot of topics involved. In fact, the assignment covers the entire module. So there's no way I will be able to take all the topics in that assignment within this presentation. So what I have done, or what I'm going to do in this presentation, is I have selected one or two topics which I'm going to address, which I'm going to discuss with you. Those topics that I selected, those are topics I think always pose kind of problems to students. And for this presentation, for computer studies, what I'm going to do, I'm going to focus on programming. As a computer studies teacher to be at the secondary school level, you cannot do without teaching student learners how to write basic programs. So programming is one of the tasks that you are going to do as a computer studies teacher after your graduation, and it is there in your course module. So what Mr. Edo is going to do, as I said this morning, is to take you through about the basic, the foundation, the basic concept of how to have a program. Are you there? Yeah. Please listen to me. Don't be distracted with your cell phones and other things. It's good to have full attention and concentration to listen to this presentation so that you can get it clearly and well understood. Okay, let us set the ball rolling. Everything that you do in life must have a foundation. If there is no foundation, then it's baseless. Now, the first thing I'm going to discuss with you here is problem solution, including algorithm design and programming concepts. What does this mean? If we are going to write a computer program, you need to have algorithm designed, and you need to understand some basic concept when it comes to programming. Now, in programming, there's what we call top-down design, which is also known as modular programming. That's what we call top-down design, which is the same thing as modular programming. But what is top-down design, or what is modular programming? A top-down design or a modular programming means that when you have a program to write, you have to break the program into smaller components. That's what top-down design means. It means breaking your program into smaller components so that each component can handle each problem of the program. Let me give you an example to drive home the point. If you remember when you were at secondary school, at your English in your English classes, you have textbooks that says Module 1, which deals with only comprehension. You have another English textbook which says Module 2, which deals with essay writing. You have another module which deals with lessons and structures, Module 3. But all together form your English course. So if you look at the English course, you have Module 1, which deals with only comprehension. You have Module 2, which deals with only maybe essay. Now, what in programming we have such a concept, meaning when you have a problem to write a computer program for, don't write one program. Don't write one program to solve that problem. Use what is called a top-down design, meaning break the problem into different components so that each component will be able to handle each particular problem. What are the advantages of having a program broken into modules? What are the advantages does it give to you as a programmer and even to the program itself when the program is broken into different components? Number one, when there are problems with the programs, it makes it very easy for the programmer to identify the problem and rectify it. So if you write a program and you break it down into various modules, when there is a problem, you know, oh, the problem is with module 1. You go there and solve the problem. But if you don't have a modular programming, you have to check the whole program to try and look for the problem. And that can take you a lot of time. Another advantage it has when you do modular programming is that each module can be tested independently. So what it means is, I'm done with module 1. Let me test it. If this is working, I'm fine. Keep it. You take module 2, you test it. This is working perfectly, keep it. I'm fine. So you can test the modules, the components independently. All right. Then, as I said before, it's easier to debug. Debug means to correct the errors, because in computer programming, bug means errors in a program. So when we say debug, we mean correct the errors in a program. Another advantage it has is that when you have a modular programming, a big program, different programmers can work on the program at the same time. So what it means is that, okay, here is a program we want to develop. Here is the contract. We have 5 programmers in the house. Oh, Mr. A work on the student registration module. Mr. B work on the student examination module. Mr. C work on the student examination module. So you can see that different programmers can work at different modules at the same time, then later they will combine it to be one module. I hope you understand what I have said. Good. I will now move to the next discussion in our presentation today, our assignment-based presentation. What next are we going to look at? We are going to look at what is called a translator. I picked some of these things from your course outline from your assignment. So what I've done, as I told you, is that I picked some facets, some concepts to explain to you. As I told you at the preamble of this, my presentation, that I'm not going to go through the entire assignment. I'm only going to focus on some critical areas which I know might pose problem to you while having the assignment done. Okay, let's keep going now. Translator. You know, when you write a program, you use a programming language because we are communicating to the computer here. You use a programming language. What it means that there are different programming languages. But the programming languages we use nowadays, they are the high-level programming languages. The high-level programming languages. But the language that the computer understands, the original language of the computer is the machine language. But we don't write our programs using machine language, no. The language the computer understands is the machine language, but we don't write our program using machine language. We use the high-level language. Now, the computer does not understand the high-level language. So if you don't understand a particular language, what do? What do you need? Can you guess? Let's say you are at the church, somebody is speaking in Spanish or somebody is speaking in Portuguese, and you don't understand Portuguese. What do? A translator is needed. Somebody needs to translate to you. The same thing applies here. So when you write a computer program, there's what we call a translator. So a translator is a piece of software that translates a program written in one language to another language. So if you write a program, a translator will translate that program from one language, basically, to the computer language, so that the computer can understand what you have just written. So for example, when you say print, write, input, the computer does not understand what you are saying. So the translator will translate it to machine language so that the computer will understand. Do you understand what I have said? Or do you need a translation? That is a joke, by the way. Now we have types of translators. We have interpreter, we have compiler, we have assembler. These are translators, meaning they can translate from one language to another language. All right. I'm not going to explain all the details here, but let me just explain a little bit about these translators. You see, the first one you have on your screen, which is the interpreter and the compiler. Both of them, they translate any program written in high-level language to machine language. But there is a difference between them. They do the same thing in different ways. What do I mean? Listen here. Interpreter, compiler, both of them, they translate from high level to low level, otherwise machine language. But the difference now is this. A compiler will translate the entire program, the entire source code, all at a time. Meaning, if you have a computer program and the computer program has 10 lines, the compiler will translate the 10 lines at the same time. But an interpreter will translate the lines one by one. That is, it translates the first line, if there is no problem, it translates the second line. If there is no problem, it translates the third line. So they both translate to low-level language, but at different ways. Then the third one, which is assembler translates from assembly language to machine language. Are you there with me? Are you listening? Please pay attention. If you listen, you will understand. I'm trying to take it slowly so that you can understand, because very soon you will become a professional colleague of mine to teach computer studies. All right. If you are going to write a program, as I told you before, you need to write in or using a computer language. There are different computer languages. And if you look at your course outline or your course module, the course module does not specify a particular language. So you can decide to write your program using any language that you understand and can use. So in doing my assignment, because in my assignment, I gave you a program to write. Now, when you are going to write your program, my beloved student, you are free to use any computer programming language. But for the purpose of emphasis, I'm going to illustrate my presentation using Pascal programming language. Because if you look at most of the examples in your study guide, it uses Pascal programming languages. So I'm trying to use a familiar programming language that is in your study guide, so that when you read your study guide with my presentation, you'll be able to marry the two together. That is why I'm using Pascal. Now, when you use a Pascal programming language, it's a high-level language. It was designed by a programmer called Pascaline. Let us not go into the history of computer here. Let's leave that for another day. All right, let's focus on the structure of a programming language called Pascal programming language. Now, on the screen, what you can see is the structure of Pascal programming language. It's like I want to build a house. This is the structure. This is the I want it to look like. So the Pascal programming language has the structure you can see on the screen. That is, you have the program, the declaration, the statement. What do I mean? If you're going to write a Pascal programming language, let me illustrate on the screen here by writing it. The first thing you are going to write is program. You see, the first thing you're going to write is here is program. Now, what do you put in front of program? You write program. What do you have in front of program? Is the program name. What do I mean by program name? The title. Can you see now? If you buy a textbook, or you buy a book, a novel, or a book to read, it has a title. So without even reading the book, the title already gives me an idea of what the book is all about. The headline news. Let me put it that way. So if I go to a bookshop, I pick a book. You say, the beautiful ones are not yet born. Whoa. Without even reading the book, I have an idea of what the book is all about. So when you say program, you put the title of your program here. A program that can calculate interest. A program to calculate loan disbursement. A program to pay salaries. A program to calculate student mark, a program to do this. What the program is going to do, what the program is all about, put it, it's kind of a heading there. Then after that, you have what is called declaration. Declaration, as you can see from the screen, declaration. Let me go back to my slide and explain from there now. Declaration. Why do you need declaration? It's a pity that this time allocated for this presentation is very short. I don't know how I'm going to meet up the whole explanation to you. But what I'm going to do, in case I'm not able to explain everything to you in this time frame, I'm going to develop a content base. Because program is one of my specialization. Basically, I have my master's degree in software engineering. So I'm going to develop a content-based presentation on programming for you. All right, so let me just go through the whole thing, because with the time left now, I'm not very sure I'll be able to go into the details. So I'm going to cut it short, beloved student. But I promise you, I do promise you, take me by my words, I'm going to design for you a content based only for programming to explain everything to you. So I'm going to run through everything because of the time left. So after program, you have your declaration. In your declaration, you declare your variables. In your variables, you declare your numeric variables, you declare your constant variables, your constant and your variables. What do I mean by variable? Let me kind of give you an idea here. A variable declaration, what do I mean by declaration? Sorry, class. Declaration is to tell the program in advance some of the things we are going to use and what they stand for. That's what I mean by declaration. Declaration means to tell the program some of the things that you are going to use in this program and what they stand for. So I will tell my program, listen, I'm going to use this word, and this is what it means. So whenever the program or the compiler come across that word, it knows what it means. Remember, a computer is not a human being, it's a machine. So it must be told some things. All right? So you have your declaration, you declare your variables and your constants. I repeat, declare your variables and your constants. Then after your declaration, you have your statements. Your statements are those instructions that tells the computer what to do, when to do it, and how to do it. Remember what a computer is. A computer takes instruction from a human being and executes it. So in your statement, that is where you write, telling the computer what to do, how to do it, and when to do it. The next slide on the screen gives you an example of a small program with this structure. Now, let me explain what this program I have on the screen can do. This is a program that can add any three numbers together. So if you give any three numbers to this program will add the numbers together and give you the answer, like a calculator. A calculator is also programmed. You see, I love programming. It's quite interesting. Okay, now, if you look at my structure, I told you that Pascal programming has a structure. Now, look at the way I arrange my structure. First of all, you see program here. It says, I just call it lesson 1 or an example 1. Then I come to my declaration now. Now, I declare my variables. Can you see that now? So when you are declaring your variable, you just write var. Then you put your variables. Now, I have 3 variables here. At this point, I need to tell you what a variable is, please. I need to tell you what a variable is, so that when I use that word variable, you say, Mr. Abel, what is a variable? So at this point, let me tell you what a variable is before I go back to that structure. A variable is like you are setting a location in your memory where a particular data will be kept. Let me use this illustration to explain to you. Look at this picture here. Your computer memory is like this. Every memory has an address. It has a name. So what you do is that, okay, computer listing in location 1011, my marks, the student marks will be there. So anytime I say location 1011, what do I have there? Student marks. So a variable is a location where data are kept within the computer, where data are kept. So now if you go back again to my slide where I discuss variable, as a set is used to set a location in the memory, and the data you have there are temporarily. So in your program declaration, you say variables, like what I said, num1, num2, and the sum, they are my variables. What type of variables are they? We have 2 types of variables. Either a variable is an integer or real. That is, if the variable has to do with numbers, which we call numeric variable. If your variable is a number, if your variable is a number, it can either be an integer or real. An integer means that variable, that numeric variable, has no decimal point. It's just a whole number. All right? So you declare your variables, then the main body of the program starts, where you have begin and end. My time is up, but I will quickly go through some of the leftover things on the presentation. So after your variable declaration, then you come to the main body of the program. My studio director have already informed me I have just 1 or 2 minutes to round off. Then let's quickly go through some other things in this presentation. Now, if you are going to write your program after your declaration, there are statements you use. Like, for example, a statement that can output an instruction. You use the writes. The statement that can output an instruction, display an information on the screen, you use the writes. Okay? So let me give you a little example of how the write work. I wish I have enough time. If I say write A like this with quotes, write A like this, what the computer will write for me on the screen, or what the computer will display on the screen, is A. But if I have like this, A is equals to 5, then I say write A. A is equals to 5. Write A, what the computer will write for me is 5. So the write makes the computer to display information on the screen. So whenever you want an information to be displayed on the screen, use write. Whenever you want an information to be read to your computer, use the statement read. Write makes the computer to be displayed on the screen. Read makes the computer to read the data into your program. What next are we going to look at? If you are going to perform your mathematical calculations, these are the operators you use: the addition, the subtraction, the multiplication. Please take note. When we talk about multiplication, we use the asterisk. It's our multiplication. Yeah, our division is this one, okay? Our division is this one. So the arithmetical operators are the ones you see on the screen. Please use them the way they should be used. Then, coming back to the statement, we have the if-then statement. We have the if-then else, which are used to make decision. Okay, I will advise you, my beloved student, to print out this presentation. Even if I don't have enough time to discuss it with you on this conduct class, please print out this presentation. Look at the if-then else, how it is being used, the syntax. Look at an example I've given to you of how to use them. So what I have done in this section is that I picked out some programming statement. If then else, while do, repeat until, for do. I gave an example of how they can be used. I know one thing. And what do I know? I know that programming can be frustrating. That I know, especially for beginners like you. But I guarantee you one thing again. I said I know one thing, and I guarantee you one thing. I will always be there for you, because it is my area of interest. It is my area of specialization. I will always be there. I guarantee you. Please, beloved student, as you go through the journey of how to become a programmer, when you have problems, please call me. Contact me. I know it's not easy to explain some things for you over the phone, but contact me. We'll fashion out a way of how to do it. But as I promised you, I'm going to design a content-based presentation strictly on how to write program. Do your assignment, computer studies. If you have a problem, please call me so that I can help you telephonically. Thank you and have a blessed day.